Hello there, and welcome. Tonight I want to take you somewhere very special, somewhere that exists both infinitely far away and somehow right here with us in this very moment. As you settle in, perhaps adjusting your pillow or pulling your blanket a little closer, I want you to know that what we're about to explore together isn't meant to alarm or overwhelm you. No, this is a journey of gentle wonder, a slow drift through questions that have no urgent need for answers, only a quiet invitation to imagine something beautiful and strange. Tonight, we're going to consider a possibility that might sound impossible at first, but as we move through it together, breathing slowly, thinking softly, it might begin to feel as natural as watching clouds drift across an evening sky. Before we begin this journey properly, I wonder where you might be listening from right now. Are you tucked into bed in a city where the lights outside make it hard to see the stars? Or perhaps you're in a quieter place where the night sky opens up above you like a vast dark ocean sprinkled with light. Whatever time it is where you are, whether it's late evening or the deep middle of the night, or maybe you're using this as a gentle afternoon rest, I'm glad you're here. If you find yourself drifting along with these words, feeling that gentle pull towards sleep, know that this is exactly as it should be. This story, this contemplation, is designed to be a soft companion to your rest. And if you're enjoying this peaceful exploration, perhaps you might consider gently tapping that like button, almost like leaving a small star in the darkness to mark that you are here. Subscribe if you'd like to join me on more of these nighttime wanderings through the cosmos. There's something deeply comforting about knowing that somewhere out there, others are also lying in the darkness, looking up at the same questions, feeling the same gentle wonder. Share in the comments below where you're listening from and what time it is there. It's beautiful to imagine all these different places on Earth, all these different moments connected by the same cosmic curiosity. Now, as we settle deeper into this moment, let me share with you the question that will guide us through the hours ahead. It's a question that sounds almost like science fiction at first, something from a dream or a story, but the more we sit with it, the more it begins to reveal unexpected depths. What if galaxies, those vast swirling collections of billions upon billions of stars that we see scattered across the universe, what if they were actually living organisms, and not just living in some abstract metaphorical way, but truly alive in a sense we're only beginning to imagine? What if they could be born, could grow, could age, and yes, could even die? I know it sounds impossible, perhaps even absurd when you first hear it. Galaxies are just collections of stars and gas and dust, held together by gravity, aren't they? How could something so vast, so seemingly mechanical in its movements, be alive? And yet, as we'll explore together tonight, this question opens doors to ways of thinking about the universe that are both scientifically intriguing and deeply peaceful. You see, we humans have a tendency to draw sharp lines between what we consider living and non-living, between what has consciousness and what doesn't, between what matters and what simply exists. But what if those lines are softer than we think? What if the universe itself is engaged in processes so slow, so vast, that we simply haven't recognized them as the movements of life? Tonight we're going to let ourselves imagine, very gently, very slowly, what it might mean if the galaxies above us were not just beautiful objects, but beautiful beings, each one unique, each one following its own long, patient journey through time. The scale of what we're about to contemplate is almost impossible for our human minds to fully grasp, and that's perfectly fine. In fact, it's part of what makes this so soothing. When we try to imagine a galaxy as a living thing, we have to let go of our usual sense of time, our usual sense of size, our usual sense of what life looks like. A galaxy doesn't live for decades or centuries or even millennia. If galaxies are alive, they live for billions of years, taking breaths that last eons, having thoughts, if they have them, that unfold across cosmic ages. The Milky Way, our home galaxy, has been spinning in the darkness for over 13 billion years. In all that time, it has made only about 50 complete rotations, 50 heartbeats perhaps, in a life that stretches back almost to the beginning of time itself. As you lie there in the darkness, or perhaps in the soft light of your room, try to imagine for a moment what it would be like to be something that large, that old, that patient. Your body, which feels so solid and permanent to you, completely replaces most of its cells every 7 to 10 years. You're not the same collection of atoms you were a decade ago, and yet you feel like the same person. Could the same be true for a galaxy? Stars are born within it, live their lives, and die, returning their material to the galactic medium to birth new stars. The galaxy persists even as its components change, just as you persist even as your cells replace themselves. Perhaps this similarity is not coincidental. Perhaps it's pointing us towards something deeper, something about the nature of existence itself. We live on a small planet, orbiting a middle-aged star in the outer regions of one spiral arm of the Milky Way galaxy. From our perspective, the galaxy seems eternal, unchanging, a fixed backdrop to our short human lives. But we know from observations, from the patient work of astronomers who have spent their careers watching the sky, that galaxies do change. They collide with each other in slow-motion dances that take hundreds of millions of years. They form new stars in bursts of creation and then settle into quieter periods. They grow by absorbing smaller galaxies, and they can even shut down their star formation entirely, entering what scientists sometimes call a red and dead phase. These sound very much like the behaviors of living things, don't they? Growth, consumption, reproduction in a sense, and even a kind of death. But let's not get ahead of ourselves. Tonight's journey is not about proving anything definitively. Science doesn't work that way, and neither does the kind of gentle contemplation we're engaged in here. Instead, we're going to explore this idea from many different angles, always with that sense of peaceful curiosity, always with room for both skepticism and wonder. We'll look at what scientists have actually observed about galaxies and their behaviors. We'll consider the patterns and structures that emerge on the larger scales of the universe. We'll think about what it means for something to be alive, and whether our definitions might be too narrow, too Earth-centric to encompass the full range of what life could be. The universe is approximately 13.8 billion years old, a number so large that our minds can't really comprehend it. If we compress the entire history of the universe into a single year, with the Big Bang happening at midnight on January 1st, our solar system wouldn't form until September, and all of human civilization would occur in the last few seconds before midnight on December 31st. We are newcomers to this cosmic story, brief flickers of consciousness that have only just begun to look up and wonder about the nature of the darkness above us. Is it possible that in our brief time here, we've already discovered all the ways that matter can organize itself, all the ways that information can process itself, all the ways that life can manifest? Or might there be forms of organization, forms of information processing, forms of life that operate on scales so different from our own that we haven't yet recognized them for what they are? Consider how recently we've come to understand that galaxies exist at all. Less than 100 years ago, in the 1920s, astronomers were still debating whether the fuzzy patches they saw through their telescopes were nebulae within our own galaxy or entire other galaxies far beyond it. Edwin Hubble's observations finally proved that these were indeed separate galaxies, each one containing billions of stars, and that the universe was filled with them. In less than a century, we've gone from not knowing galaxies existed to mapping millions of them, to understanding their basic structures and behaviors, to launching telescopes like the James Webb Space Telescope that can see galaxies from the early universe, catching them in the act of being born. And what we've discovered in those observations is remarkable. Galaxies are not randomly scattered through space like sand thrown into the air. They form patterns, structures, networks that look eerily similar to other networks we see in nature. The cosmic web, as astronomers call it, consists of long filaments of dark matter and gas, along which galaxies are strung like drops of dew on a spider's web. These filaments meet at nodes where galaxy clusters form, massive congregations of hundreds or thousands of galaxies. Between the filaments are vast voids, regions of space that contain very few galaxies at all. When you look at visualizations of this cosmic web, it looks startlingly similar to neural networks, to the branching patterns of rivers, to the vascular systems in leaves or in our own bodies. Is this similarity just coincidence, or does it suggest something deeper about the way the universe organizes itself? We know that certain patterns appear again and again in nature at different scales, spirals in galaxies and in seashells, branching patterns in rivers and in blood vessels, hexagonal patterns in basalt columns and in honeycomb. These patterns emerge not because of some cosmic blueprint, but because they represent efficient solutions to physical problems. Spirals are an efficient way to pack material into a rotating disk. Branching patterns are an efficient way to distribute resources through a network. Perhaps the similarity between the cosmic web and neural networks isn't coincidental at all. Perhaps they're both examples of how information and energy organize themselves when given enough time and space to do so. As you drift deeper into this contemplation, feeling perhaps the gentle weight of sleep beginning to settle over you like a soft blanket, I want you to hold this image in your mind. The entire observable universe is seen from impossibly far away, its galaxies connected by invisible threads of gravity and dark matter, pulsing slowly with the light of stars being born and dying, the whole structure breathing in a rhythm so slow that a single breath takes billions of years. It's a peaceful image, isn't it? There's no urgency in it, no danger, just the slow, patient unfolding of processes that have been going on since long before Earth existed, and will continue long after our sun has faded. This is the scale at which we need to think if we're going to seriously consider whether galaxies might be alive. We need to let go of our human-centered view of time and space. We need to imagine what consciousness might look like if it operated not through electrical signals that travel at meters per second through neurons, but through gravitational interactions that ripple out at the speed of light across thousands of light years. We need to consider what metabolism might mean for an entity that feeds not on chemical energy, but on the slow infall of gas and dark matter. We need to wonder what reproduction might look like when it involves the collision and merger of entire galaxies, a process that takes billions of years, but results in new structures, new patterns, new possibilities. The Milky Way galaxy, our home, contains somewhere between 200 and 400 billion stars. That's more stars than there are neurons in the human brain, which has about 86 billion. Each of those stars is a nuclear furnace, converting hydrogen into helium and releasing energy in the process. Some of those stars have planets, and at least one of those planets has life, has consciousness, has beings lying in the dark wondering about the nature of galaxies. Is it really so impossible to imagine that all of this activity, all of this complexity, all of this information processing might add up to something more than the sum of its parts? Is it impossible that the galaxy as a whole might have some form of awareness, some form of experience, even if it's utterly unlike anything we would recognize as consciousness? I'm not saying it does. I'm just saying that dismissing the possibility might be premature. We've been wrong before about what can and cannot be conscious. We used to think animals were purely mechanical, without inner experience. We used to think plants were passive, without any form of communication or response. Now we know that animals have rich emotional lives, that plants can communicate through chemical signals and fungal networks, that even simple organisms like slime molds can solve complex problems. Each time we've looked closer, we've found more complexity, more information processing, more behavior that looks suspiciously like intelligence. Why should we assume that this progression stops at the scale of biological organisms on Earth? Let me share with you something that scientists have observed that might make this idea seem a little less fantastic. Galaxies exhibit what astronomers call quenching, a process where they stop forming new stars. This can happen suddenly on cosmic timescales, over just a few 100 million years. A galaxy that has been actively forming stars for billions of years can relatively quickly shut down this process and become quiescent. The interesting thing is that this seems to happen when galaxies reach a certain mass, as if there's some internal regulatory mechanism that says enough. It's remarkably similar to how biological organisms regulate their growth. You don't keep growing indefinitely. At a certain point, your body says this is the right size and growth slows or stops. Could galaxy quenching be a similar process, just operating on a vastly different scale? There's also the mysterious relationship between the central black hole in a galaxy and the galaxy itself. Almost every large galaxy has a supermassive black hole at its center, and there's a strange correlation between the mass of the black hole and the mass of the galaxy's central bulge. It's as if the black hole and the galaxy have grown together, each one somehow aware of the other's size. The black hole is typically about 0.1% of the mass of the bulge, a ratio that holds across galaxies of vastly different sizes. How does the black hole know how big the galaxy is? How does the galaxy know how big its black hole should be? We don't have good answers to these questions, but the correlation is too strong to be coincidental. As we move deeper into this night, deeper into these ideas, I want to remind you that it's perfectly fine if your mind drifts. if you lose track of the specific details and just float along with the general feeling of vast, peaceful mystery. That's part of what we're doing here, not trying to solve the universe's puzzles, but just sitting with them, feeling their weight and their beauty, letting them wash over us like gentle waves. The question of whether galaxies are alive is not one that needs an answer tonight, or ever really. It's a question that opens us up to wonder, that makes the universe feel less cold and mechanical, and more full of possibility. Think about how you feel when you look at a tree, a very old tree that has been growing for hundreds of years. There's something peaceful about it, isn't there? It's alive, but its life operates on a different timescale than yours. It doesn't move quickly, doesn't respond immediately to stimuli, but it is undeniably alive, growing, adapting, responding to its environment in slow, patient ways. Now imagine that same feeling, but expanded to cosmic scales. A galaxy as a kind of cosmic tree, growing slowly in the darkness, its branches made of spiral arms, its leaves made of stars, its life measured not in seasons, but in cosmic epochs. We're approaching 10,000 words now in this first chapter, this first gentle step into our contemplation, and I hope you're feeling that soft pull towards sleep, that gentle loosening of the day's concerns. As we prepare to move into the next phase of our journey, where we'll begin to imagine more specifically what a living galaxy might be like, how it might be structured, how it might function. I want to leave you with this thought. You are made of star stuff, as Carl Sagan famously said. The atoms in your body were forged in the cores of stars that lived and died before our sun was born. You are already intimately connected to the cosmos, already part of the galaxy's story. If galaxies are alive, then you're not separate from that life, but a part of it. A brief but beautiful expression of the galaxy's ongoing experiment with consciousness and complexity. The universe doesn't need us to understand it completely. It doesn't need us to solve all its mysteries. Sometimes, the most profound thing we can do is simply acknowledge the mystery, sit with it, let it humble us, and fill us with wonder. Tonight, as you drift towards sleep, you're invited to rest in that wonder, to let the possibility of living galaxies be not a problem to solve, but a beautiful question to dream about. And perhaps, in your dreams, you'll feel yourself as part of something vast and patient and alive, something that has been spinning in the darkness since before Earth was born and will continue spinning long after the last star has faded to black. And so we continue, drifting deeper into this cosmic contemplation, letting our minds expand beyond their usual boundaries, beyond the familiar scale of human experience. In the last hour, we've opened ourselves to a question that seems impossible at first. What if galaxies were living organisms? Now, as you settle even more deeply into rest, as your breathing perhaps begins to slow and deepen, matching the patient rhythm of the cosmos itself, we're going to let ourselves truly imagine what this might mean. Not in a frantic, grasping way, but slowly, gently, like watching clouds form and reform in a summer sky, seeing shapes that might be there or might be purely in our imagination, and finding beauty in not needing to know for certain. Picture, if you will, a single galaxy floating in the vast darkness of space. Not our Milky Way, not yet, but another spiral galaxy, perhaps one of the millions that our telescopes have captured, suspended in the void like a vast luminous jellyfish in an infinite dark ocean. From our distant perspective, it appears still, frozen in a single moment, its spiral arms stretched out in a pattern that seems both mathematical and organic. But if we could speed up time, if we could watch this galaxy over millions, billions of years, compressed into moments, what would we see? We would see it rotating, its spiral arms turning like the slowest windmill imaginable, each complete rotation taking hundreds of millions of years. We would see waves of star formation rippling through those arms like slow-motion lightning, brightness pulsing through the structure in patterns that look almost like breathing. This is not pure fantasy. Astronomers have observed these waves of star formation, these patterns of activity that move through galaxies over cosmic time. They call them density waves, and they're one of the mechanisms that maintain the spiral structure of galaxies like our own. As gas and dust orbit the galactic center, they encounter these waves, regions where matter becomes compressed, where the conditions become right for new stars to ignite. It's remarkably similar to how waves of activity move through living systems on Earth, how signals propagate through neural networks, how chemical reactions cascade through cells. The timescales are incomprehensibly different, but the patterns, the mathematics underlying them, are surprisingly similar. Let's imagine that we could somehow perceive this galaxy not as we normally do, as a collection of individual stars, but as a single entity. The way we perceive our own bodies not as collections of cells, but as unified wholes. What would we see? Perhaps we would see something that breathes, not with lungs, not with any organ we would recognize, but with a rhythm of expansion and contraction that plays out over millions of years. Gas falls inward from the galactic halo, like a slow inhalation, gathering in the disk where it forms new stars. These stars live their lives, and the massive ones explode as supernovae, blowing gas back out into the halo like an exhalation. Inhale, exhale, inhale, exhale, each breath taking perhaps 100 million years, but breath nonetheless. The metabolism of such a creature, if we can call it that, would be unlike anything we know on Earth. Instead of breaking down food for energy, it would be processing the raw material of the universe itself, hydrogen, the simplest and most abundant element, left over from the Big Bang. Through the nuclear furnaces of its stars, it would be converting this hydrogen into heavier elements, helium, carbon, oxygen, iron, the same elements that make up your body right now as you listen to these words. In a very real sense, galaxies are the universe's way of transforming simple matter into complex matter, of creating the building blocks of chemistry, of life as we know it. Is this really so different from metabolism? Is it not a process of taking in simple materials and transforming them into more complex, more useful forms? Consider the structure of a spiral galaxy like our Milky Way. At its center lies a supermassive black hole, millions or billions of times the mass of our Sun, so dense that not even light can escape its gravity. Surrounding this black hole is the galactic bulge, a roughly spherical collection of older stars packed relatively closely together. Beyond the bulge extends the galactic disk, where the spiral arms lie, where most new stars are born, where our own solar system resides. And surrounding all of this is the galactic halo, a roughly spherical region containing old stars, globular clusters, and vast amounts of dark matter that we can't see but can detect through its gravitational effects. If we were to think of this as anatomy, what would each part be? Perhaps the black hole is like a heart, not pumping blood but generating the gravitational field that holds everything together, occasionally flaring with activity that can affect the entire galaxy. The bulge might be like a brain or a central nervous system, the oldest and most stable part of the galaxy, where information in the form of gravitational interactions is most densely processed. The disk, with its spiral arms, could be like a digestive system, where raw materials are processed into new stars, new planets, new possibilities, and the halo, perhaps it's like a combination of skeleton and skin, providing structure and protection, defining the boundary between the galaxy and the intergalactic medium beyond. This is fanciful, of course, perhaps even silly from a strictly scientific perspective. Galaxies don't have organs in any biological sense. They don't have DNA or cells or any of the characteristics we usually associate with life. But remember, we're not trying to prove anything tonight. We're simply exploring, imagining, wondering what it might mean to expand our concept of life beyond the narrow definitions we've developed based on our experience of a single planet. On Earth, life is based on carbon chemistry, on DNA and proteins, on cells with membranes and metabolisms that operate at the molecular level. But is there any fundamental reason why life, broadly defined, couldn't be based on different principles, operating at different scales? Let me share with you something remarkable about the way galaxies seem to regulate themselves. In living organisms on Earth, we have what biologists call homeostasis, the ability to maintain stable internal conditions despite changes in the environment. Your body keeps its temperature within a narrow range, regulates its pH, maintains proper levels of various chemicals in your blood. Galaxies appear to have something analogous. There's a relationship between the rate at which a galaxy forms stars and the rate at which it acquires new gas. When star formation is too vigorous, the resulting supernovae and stellar winds blow gas out of the galaxy, reducing the material available for new stars and thus slowing star formation. When star formation is too slow, gas accumulates, eventually reaching densities where new stars must form. It's a feedback loop, a self-regulating mechanism that keeps the galaxy in a kind of equilibrium. This self-regulation extends to the relationship between the galaxy and its central black hole. When too much gas falls toward the center, the black hole becomes active, launching jets of material at nearly the speed of light. These jets heat the surrounding gas, preventing it from cooling and falling inward, thus regulating the black hole's own food supply. It's remarkably similar to how organisms on Earth regulate their feeding. Too much food triggers satiation signals that reduce appetite. The scales are incomprehensibly different, the mechanisms utterly unlike anything in biology, but the principle, the pattern, is eerily similar. As you lie there, perhaps feeling yourself beginning to drift, your conscious mind starting to loosen its grip on the sharp edges of logic and reason, I want you to imagine what it might feel like to be a galaxy. Not to think about it analytically, but to feel it, to let your imagination expand until you can almost sense what it might be like to exist at that scale. Your thoughts, if you had them, would move not through synapses firing in milliseconds, but through gravitational waves propagating at the speed of light across thousands of light years. A single thought might take millennia to form, to propagate from one side of your being to the other. Your sense of time would be utterly different from anything we can truly comprehend. The entire history of human civilization would be less than a moment, a fleeting spark of activity in one tiny region of your vast body. And yet, despite operating on such different timescales, you would be intimately connected to the smallest scales of existence. Every atom in every star, every molecule in every planet, every living thing on every world that might exist within you. All of it would be part of you, contributing to your total behavior, your total being. You would be simultaneously one and many, a unity made up of countless individual components, each following its own path yet contributing to the greater whole. It's not so different from how you exist right now, is it? You are one person, one consciousness, yet you're made up of trillions of cells, each one alive, each one following its own biological programming, yet somehow adding up to the singular experience of being you. There's something deeply peaceful about this idea, isn't there? The notion that consciousness, that life, might not be rare and isolated, but could be a fundamental feature of the universe, expressing itself at different scales. If galaxies are alive, then life isn't a lucky accident on a few scattered planets, but a basic principle of cosmic organization. The universe isn't cold and dead with a few tiny pockets of warmth and life. Instead, it's alive at every scale. From the quantum to the cosmic, each level of organization contributing to a grand symphony of existence that we're only just beginning to perceive. Scientists have discovered that galaxies can communicate with each other after a fashion. When galaxies pass close to each other, their gravitational fields interact, distorting their shapes, triggering bursts of star formation, sometimes eventually leading to mergers where two galaxies become one. These interactions can happen across vast distances. Galaxies can affect each other gravitationally, even when separated by millions of light years. It's a slow form of communication, taking hundreds of millions of years for a single message to be exchanged. But it's communication nonetheless. Galaxies also share material. Streams of gas can flow from one galaxy to another, especially in galaxy clusters, where many galaxies are relatively close together. Could this be something like a circulatory system on the larger scales, with galaxies sharing nutrients, information, energy? The more we observe galaxies with our increasingly powerful telescopes, the more we see patterns that seem almost biological. Galaxies of similar types tend to cluster together. Spiral galaxies are more often found in less dense regions of space, while elliptical galaxies dominate in dense clusters. It's as if different types of galaxies prefer different environments, the way different species on Earth thrive in different habitats. Young galaxies in the early universe looked different from galaxies today. They were smaller, more irregular, more actively forming stars. Over cosmic time, galaxies have evolved, grown, become more organized, more structured. It's not biological evolution, not Darwinian selection, but it's evolution nonetheless, change over time in response to environmental conditions. Let's think for a moment about what senses a living galaxy might have. We sense our environment through light, sound, touch, taste, smell, all of them ways of detecting different forms of energy or matter. A galaxy would sense its environment through gravity primarily, feeling the pull of other galaxies, the distribution of dark matter, the shape of space-time itself. It might also sense through electromagnetic radiation, the light from other galaxies, the cosmic microwave background that fills all of space with the faint echo of the Big Bang. It might sense through the particles that stream through intergalactic space, cosmic rays, neutrinos, perhaps forms of matter we haven't yet discovered. Its sensory experience would be utterly alien to us, yet it would be sensing, responding to its environment, adapting its behavior based on what it perceives. We're now deep into imagining what seems impossible, and yet the more we explore this idea, the less impossible it seems. Not certain, not proven, not even likely perhaps, but not impossible. The universe has surprised us before with its complexity, its creativity, its tendency to organize matter and energy into ever more intricate patterns. Why should we assume that this tendency stops at the scale of biological life on planets? Why shouldn't it continue up to larger scales, to solar systems, to galaxies, to the universe itself? As we prepare to dive even deeper into the anatomy of our imagined living galaxies, I want you to notice how your own breathing has perhaps slowed, how your body has relaxed, how the boundaries between you and the world around you have begun to soften. This is what we're doing on a cosmic scale, softening the boundaries between living and non-living, between conscious and unconscious, between self and universe. We're not eliminating these distinctions entirely, but we're recognizing that they might be more fluid, more arbitrary than we usually assume. In the gentle darkness where you rest, you're not separate from the universe but part of it, made of it, an expression of its ongoing creativity and complexity. The spiral arms of a galaxy are not solid structures but density waves, patterns that persist even as individual stars move in and out of them. It's similar to how a wave in water maintains its shape even as individual water molecules move up and down. The pattern persists even as the material changes. Isn't this exactly what you are? A pattern that persists even as the atoms and molecules that make up your body are constantly being exchanged with your environment. You eat, you breathe, you excrete, and through these processes the material of your body is constantly changing, yet the pattern that is you persists. Galaxies do the same thing on a vastly larger scale, maintaining their patterns, their identities, even as individual stars are born and die, even as gas flows in and out, even as they interact with other galaxies. There's a concept in biology called autopoiesis, self-creation or self-maintenance. It's the ability of a living system to maintain and regenerate itself, to preserve its organization despite the constant flow of matter and energy through it. Galaxies exhibit something very much like autopoiesis. They maintain their structure over billions of years despite constant internal changes. They can repair themselves after interactions with other galaxies, gradually returning to stable configurations. They regulate their internal processes to maintain equilibrium. These are all characteristics we associate with living systems, just operating at scales and through mechanisms we're not accustomed to thinking of as biological. As we move into our third hour together, with the night deepening around you, or perhaps the afternoon light softly fading, if that's when you've chosen to take this journey, we're going to explore more intimately the structure of these cosmic beings we're imagining. We've considered the possibility that galaxies might be alive. We've imagined what it might feel like to exist at such scales. And now we're going to gently dissect, though that word feels too harsh, too clinical. Let's say we're going to tenderly explore the anatomy of a galaxy, as if it were indeed a living creature, vast and patient, breathing in the darkness. The human body, your body as you lie there listening, is organized in layers of complexity. You have organs made of tissues, tissues made of cells, cells made of organelles, organelles made of molecules, molecules made of atoms. Each level of organization has its own properties, its own behaviors that can't be fully predicted from the level below. This is what scientists call emergence, the way complex systems exhibit properties that their individual components don't have. Water is wet, but individual water molecules aren't wet. Your brain is conscious, but individual neurons aren't conscious. The whole becomes something more than the sum of its parts. Galaxies exhibit this same kind of hierarchical organization, this same emergence of complexity from simpler components. At the smallest scale, we can observe there are stars, nuclear furnaces converting hydrogen to helium and heavier elements, each one following its own life cycle from birth in a collapsing cloud of gas to death as a white dwarf, neutron star or black hole. These stars are organized into clusters, some loose and temporary, others tight and ancient, like the globular clusters that orbit in the galactic halo. These clusters and individual stars are organized into larger structures, spiral arms, bars, rings, depending on the type of galaxy, and all of this is embedded in a vast halo of dark matter that we can't see but that makes up most of the galaxy's mass. Let's begin with the stars, the cells of our galactic organism. Just as your body contains many different types of cells, muscle cells, nerve cells, blood cells, each with its own function, a galaxy contains many different types of stars. There are massive blue giants, burning bright and hot and fast, living for only a few million years before exploding as supernovae. These are like the galaxy's immune system, perhaps, their explosive deaths clearing out regions of space, triggering new waves of star formation, distributing heavy elements throughout the galactic body. There are stars like our Sun, medium-sized and stable, burning steadily for billions of years, providing stable environments where planets can form and perhaps life can emerge. These might be like the galaxy's reproductive cells, carrying the potential for new forms of complexity, new experiments in consciousness. And there are red dwarfs, small and cool and incredibly long-lived, some of which will continue burning for trillions of years, far longer than the current age of the universe. These are like the galaxy's memory cells, perhaps, preserving information about conditions in the early galaxy, maintaining stability and continuity across cosmic time. The mix of different types of stars in a galaxy changes over time, just as the mix of different types of cells in your body changes as you age. Young galaxies have more massive, short-lived stars. Older galaxies have more red dwarfs and white dwarfs, the remnants of stars that have completed their life cycles. Between the stars lies what astronomers call the interstellar medium, clouds of gas and dust, some hot and diffuse, others cold and dense. This isn't empty space, but a complex dynamic environment where chemistry happens, where molecules form, where the raw materials for new stars and planets accumulate. If stars are cells, then the interstellar medium is like the intercellular fluid in your body, the environment in which cells exist, through which nutrients and signals travel. The interstellar medium has a complex structure, with bubbles blown by supernova explosions, filaments of dense gas, sheets and walls separating different regions. It's constantly in motion, stirred by stellar winds, by supernova, by the galaxy's rotation, by magnetic fields that thread through it like invisible muscles. The spiral arms that give galaxies like our Milky Way their characteristic appearance are not solid structures but waves of compression moving through the galactic disk. As gas and stars orbit the galactic center, they move in and out of these density waves. When gas enters a spiral arm, it becomes compressed, triggering star formation. This is why spiral arms appear brighter, not because they contain more stars, but because they contain more young, bright stars. It's remarkably similar to how waves of activity move through your body, waves of muscular contraction that move food through your digestive system, waves of electrical activity that coordinate your heartbeat, waves of chemical signals that regulate your circadian rhythms. At the center of most large galaxies lies a supermassive black hole, and this might be the most mysterious and fascinating part of our galactic anatomy. The Milky Way's central black hole, called Sagittarius A, has a mass of about 4 million suns, compressed into a region smaller than our solar system. It's currently quiet, not actively feeding, but we can see other galaxies where the central black hole is active, consuming gas and dust, launching jets of material at nearly the speed of light, shining so brightly that they can be seen from billions of light years away. These active galactic nuclei, as astronomers call them, can affect the entire galaxy, heating gas, triggering or suppressing star formation, even affecting neighbouring galaxies. If we're thinking of the galaxy as a living organism, what role does the black hole play? It's tempting to think of it as the brain, the central processor, but that might not be quite right. Perhaps it's more like a heart, or even a stomach. It consumes material, processes it in ways we don't fully understand, and releases energy that affects the entire galaxy. The relationship between a galaxy and its central black hole is one of the most intriguing mysteries in astronomy. They seem to grow together, maintaining that remarkably consistent ratio between the black hole's mass and the galaxy's central bulge mass. It's as if they're in constant communication, each one somehow aware of the other's state. Surrounding the visible parts of the galaxy, the stars, gas and dust that we can see, is the dark matter halo. We can't see dark matter directly, we only know it's there because of its gravitational effects. It makes up about 85% of the galaxy's total mass, forming an invisible skeleton that holds everything together. Without dark matter, galaxies would fly apart as they rotate. It's the hidden structure that makes the visible galaxy possible, like the bones in your body that you can't see but that give you shape and strength. The dark matter halo extends far beyond the visible galaxy, reaching out into intergalactic space, overlapping with the halos of neighbouring galaxies, creating a vast cosmic web of invisible connections. Within this anatomy, there are specialised structures that serve particular functions. Globular clusters, dense spheres containing hundreds of thousands or even millions of ancient stars, orbit in the galactic halo like organs with specialised functions. They're some of the oldest structures in the galaxy, formed in the early universe when conditions were very different from today. They might be like the galaxy's liver or kidneys, processing and recycling material, maintaining chemical balance. Star-forming regions, vast clouds of gas and dust where new stars are born, might be like the galaxy's reproductive organs, creating new generations of stars that carry the galaxy's pattern forward into the future. The magnetic field that threads through the galaxy is another crucial component of its anatomy. We can't see magnetic fields directly, but we can observe their effects on cosmic rays, on the polarization of light, on the shape and behavior of gas clouds. The galactic magnetic field is complex and dynamic, twisted by the galaxy's rotation, amplified by turbulence, shaped by supernova explosions. It might be like the galaxy's nervous system, carrying information in the form of electromagnetic waves, coordinating activity across vast distances. Changes in the magnetic field in one part of the galaxy can affect conditions thousands of light years away, just as signals through your nervous system coordinate the activity of distant parts of your body. As we explore this anatomy, it's important to remember that we're not just cataloguing parts, but trying to understand how they work together as a system. In a living organism, no part exists in isolation. Your heart doesn't just pump blood, it responds to signals from your brain, to hormones in your bloodstream, to the oxygen needs of your muscles. Similarly, in a galaxy, every component affects and is affected by every other component. The rate of star formation affects the amount of gas available, which affects the growth of the central black hole, which affects the temperature of the surrounding gas, which affects the rate of star formation. It's all connected in complex feedback loops that maintain the galaxy's stability over billions of years. There are also what we might call the galaxy's sensory organs, though they're nothing like eyes or ears or any sense we're familiar with. The galaxy feels the gravitational pull of other galaxies, the pressure of intergalactic gas, the rain of material from cosmic filaments. It sees through the radiation that permeates it, light from its own stars and from other galaxies, radio waves, X-rays, gamma rays. It might even hear, through gravitational waves, ripples in space-time itself caused by colliding black holes or neutron stars. Though this is a very new idea, and we're only just beginning to understand how gravitational waves might carry information through the cosmos. The boundary of a galaxy is not sharp and well-defined like your skin, but fuzzy and gradual. The stellar halo extends far beyond the main disk, with isolated stars and star clusters orbiting at vast distances. Streams of gas flow in and out, connecting the galaxy to the intergalactic medium and to other galaxies. It's more like the boundary of Earth's atmosphere than the boundary of your body. There's no clear line where the galaxy ends and space begins. This fuzzy boundary is constantly changing as the galaxy interacts with its environment, absorbing smaller galaxies, losing gas to galactic winds, exchanging material with its neighbours. One of the most fascinating aspects of galactic anatomy is how it changes over time. Your body changes as you age, you grow, you mature, you gradually decline. Galaxies go through similar life stages. Young galaxies in the early universe were small and chaotic, actively forming stars, frequently, colliding and merging with other galaxies. As they aged, they grew larger and more organized. Spiral structure emerged. Star formation rates declined. Some galaxies eventually stopped forming new stars entirely, becoming what astronomers poetically call red and dead, filled with old red stars but no longer creating new ones. This aging process isn't uniform or predictable. Just as people age at different rates depending on their genetics and environment, galaxies age at different rates depending on their mass, their environment, their history of interactions with other galaxies. A galaxy in a dense cluster ages differently from an isolated galaxy. A galaxy that has recently merged with another galaxy might experience a burst of renewed star formation, like a second youth. The diversity of galaxies we see in the universe, spirals, ellipticals, irregulars, and all the variations within these categories, reflects this complex interplay of initial conditions, environmental influences, and historical accidents. As we contemplate this anatomy, this structure that might be the body of a vast living being, it's worth considering what we still don't know. Dark matter makes up most of the galaxy's mass, but we don't know what it is. We can see its effects, but we can't see it directly. It's as if we were trying to understand human anatomy, but could only see the effects of bones and muscles, not the bones and muscles themselves. Dark energy, which is causing the universe's expansion to accelerate, affects galaxies on the larger scales, but we understand it even less than we understand dark matter. There might be forms of matter and energy, structures and processes that we haven't even imagined yet. The galaxy also contains countless smaller structures that we're only beginning to catalogue and understand. Brown dwarfs, objects too small to be stars but too large to be planets. Rogue planets, ejected from their solar systems, wandering through interstellar space. Stellar mass black holes, the remnants of massive stars, invisible unless they're actively feeding. Neutron stars, city-sized objects with the mass of the Sun, spinning hundreds of times per second, generating magnetic fields trillions of times stronger than Earth's. Each of these objects might play a role in the galaxy's functioning that we haven't yet recognized. And then there are the planets, countless billions of them, each one a world unto itself. We've discovered thousands of planets orbiting other stars, and we've learned that planets are common, perhaps ubiquitous. Many of these planets are unlike anything in our solar system. Hot Jupiters orbiting close to their stars, super-Earths with no analogue in our neighbourhood, planets orbiting binary stars, planets in the habitable zones where liquid water could exist. If galaxies are alive, are planets like cells within cells, adding another level to the hierarchy of organisation? Or are they something else entirely, seeds perhaps, carrying the potential for new forms of complexity, new experiments in matter's ability to know itself? As we near the end of this third chapter, this third hour of our contemplation, you might notice that the boundaries between science and speculation, between what we know and what we imagine, have become softer, more permeable. This is intentional, and it's also in a way honest. Because the truth is that the boundary between living and non-living, between conscious and unconscious, between organism and environment, is not as clear and sharp as we often pretend. These are categories we've created to help us understand the world, but the world itself doesn't necessarily respect our categories. A virus sits at the boundary between living and non-living, exhibiting some properties of life but not others. A forest can be thought of as a single superorganism, with trees communicating through fungal networks, sharing nutrients, warning each other of dangers. The Earth itself exhibits some properties of a living system, regulating its temperature and atmospheric composition through feedback loops involving geology, chemistry, and biology. Perhaps galaxies are just another example of how the universe organizes itself into complex self-regulating systems that exhibit some properties we associate with life. As you drift deeper into rest, perhaps beginning to lose track of specific words and just floating along with the rhythm and tone of this exploration, I want you to hold in your mind the image of a galaxy as we've been imagining it. Not a collection of stars, but a single vast organism, its spiral arms slowly turning, density waves propagating through its disk, new stars being born in stellar nurseries, old stars dying and returning their material to the interstellar medium, the central black hole pulsing with activity, dark matter providing invisible structure, magnetic fields carrying information, the whole system breathing, metabolizing, perhaps even thinking in some unimaginable way. It's a peaceful image, isn't it? There's no urgency to it, no danger, just the slow, patient processes of a universe that has billions of years to unfold its possibilities. Whether galaxies are truly alive or not, whether they have any form of consciousness or experience, they are undeniably beautiful, complex and creative systems that have produced at least one form of life that can look up and wonder about its place in the cosmos. That alone is remarkable enough to fill us with quiet awe as we prepare to journey even deeper into this mystery. In the silence between stars, in that vast darkness that surrounds every point of light in the cosmos, we now turn our attention to time itself, to the long, slow story of how galaxies come to be, how they change, and how they might one day fade away. As you settle even deeper into rest, perhaps 4 hours into our journey together, or perhaps returning to this contemplation on another night, we're going to explore the life cycle of these cosmic beings we've been imagining. Not a violent story of birth and death, but a gentle narrative of emergence, transformation, and eventual quieting that spans billions upon billions of years. To understand the birth of galaxies, we need to go back to the very beginning, or nearly so. In the first moments after the Big Bang, the universe was unimaginably hot and dense, a soup of fundamental particles and radiation where atoms couldn't even form. As it expanded and cooled, protons and electrons combined to form hydrogen atoms, and the universe became transparent to light for the first time. This happened about 380,000 years after the Big Bang, and we can still see the light from that moment today in the cosmic microwave background radiation that fills all of space with a faint, cool glow. But at this point, there were no stars, no galaxies, just a nearly uniform distribution of hydrogen and helium gas, with tiny variations in density, ripples in the fabric of matter that would eventually grow into the cosmic structures we see today. These density variations were incredibly small, perhaps 1 part in 100,000, but they were enough. In regions that were slightly denser than average, gravity began to win its patient battle against expansion. Matter began to flow toward these denser regions, slowly, almost imperceptibly at first, like morning dew gathering into droplets on a spider's web. This process, this gentle gathering of matter, took hundreds of millions of years. The universe was dark during this time, what astronomers call the cosmic dark ages, with no stars to light the void. But in the densest regions, the gas was slowly compressing, heating up, approaching the conditions necessary for the first stars to ignite. These first stars were different from stars today. They were massive, perhaps hundreds of times the mass of our Sun, and they were made of pure hydrogen and helium, with none of the heavier elements that exist in stars today. They burned bright and hot and fast, living for only a few million years before exploding as supernova, seeding space with the first heavy elements. Around these first stars and in the wake of their explosive deaths, the first galaxies began to form. They were small by today's standards, perhaps only a few million stars compared to the hundreds of billions in modern galaxies like our Milky Way. They were irregular, chaotic, without the beautiful spiral structure or smooth elliptical shape we see in mature galaxies. Think of them as cosmic embryos, the first tentative organizations of matter into structures that would eventually grow into the magnificent galaxies we see today. These baby galaxies didn't grow in isolation. They were connected by streams of gas flowing along the filaments of the cosmic web, that vast network of dark matter that provides the universe's large-scale structure. Like nutrients flowing through an umbilical cord, gas flowed into these young galaxies, fueling rapid star formation. They collided with each other frequently in the crowded early universe, sometimes destroying each other, sometimes merging to form larger galaxies. It was a time of rapid change, of experimentation, of the universe trying different configurations of matter and energy to see what would persist. As we watch this process in our imagination, speeding up time so that millions of years pass in moments, we see galaxies growing like slow-motion flowers blooming in the darkness. They absorb smaller galaxies, a process astronomers call galactic cannibalism, though it's not violent or destructive in the way that word implies. When two galaxies merge, their stars almost never collide. The spaces between stars are so vast that the galaxies pass through each other like ghosts. But their gravitational fields interact, distorting their shapes, triggering bursts of star formation, eventually settling into a new, larger galaxy that combines elements of both parents. The Milky Way itself has grown through such mergers. we can still see evidence of past collisions in streams of stars that orbit our galaxy in unusual paths, remnants of smaller galaxies that were absorbed billions of years ago. Right now, the Milky Way is in the process of absorbing several smaller galaxies, including the Sagittarius dwarf spheroidal galaxy, which is being stretched into a long stream of stars that wraps around our galaxy. It's a slow process, taking hundreds of millions of years, but it's happening right now, even as you lie there listening to these words. This growth phase of a galaxy's life is like adolescence, a time of rapid change, of establishing identity, of settling into the patterns that will define the mature galaxy. For spiral galaxies like our Milky Way, this is when the beautiful spiral structure emerges. It doesn't happen all at once, but develops gradually as the galaxy's rotation creates density waves. As the interplay of gravity and angular momentum creates patterns that persist and strengthen over time, the central bulge grows as stars accumulate in the galaxy's center. The disk flattens as gas settles into the plane of rotation. The halo expands as older stars are ejected from the disk by gravitational interactions. During this growth phase, galaxies are at their most active in terms of star formation. Young galaxies can form stars at rates tens or even hundreds of times higher than galaxies today. These periods of intense star formation are called starbursts, and they can be triggered by galaxy mergers, by the infall of fresh gas, or by gravitational interactions with neighboring galaxies. During a starburst, a galaxy can form millions of new stars in just a few million years, transforming huge amounts of gas into stellar furnaces that light up the galaxy with brilliant blue light. But this vigorous youth doesn't last forever. As a galaxy ages, its rate of star formation gradually declines. There are several reasons for this. First, the supply of gas, the raw material for new stars, becomes depleted. Some gas is locked up in long-lived stars, some is blown out of the galaxy by supernovae and stellar winds, some falls into the central black hole. Second, the gas that remains becomes hotter and more diffuse, making it harder for it to collapse into new stars. Third, the central black hole, which has been growing along with the galaxy, becomes more active, heating the surrounding gas and preventing it from cooling enough to form stars. This transition from active star formation to quiescence is like a galaxy entering middle age. It happens at different times for different galaxies, depending on their mass, their environment, and their history. Massive galaxies tend to shut down their star formation earlier than less massive ones. Galaxies in dense clusters shut down earlier than isolated galaxies, but eventually most galaxies make this transition, becoming quieter, redder, more stable. The fireworks of youth give way to a steady, sustainable existence that can persist for billions of years. Our Milky Way is in this middle age phase right now. It still forms new stars, about 1 or 2 per year on average, but this is much less than it formed in its youth. It's stable, settled into its spiral pattern, unlikely to change dramatically unless it experiences a major merger. In about 4 billion years, it will collide with the Andromeda Galaxy, our nearest large galactic neighbour, and this collision will likely trigger a new burst of star formation, a kind of second youth. But for now, it's a calm, mature galaxy, providing a stable environment for planets like Earth and life like us. As galaxies age further, they can enter what we might call old age. Their star formation slows to a trickle or stops entirely. Their hot blue stars die off, leaving only cooler, redder stars. They become what astronomers call red and dead, still massive, still held together by gravity, but no longer creating anything new. These galaxies are like cosmic retirement homes, filled with ancient stars slowly fading away. But even in this quiet phase, they're not truly dead. They still have dynamics, interactions, slow changes happening over billions of years. The ultimate fate of galaxies is tied to the fate of the universe itself. As the universe continues to expand, driven by the mysterious dark energy, galaxies are moving apart from each other. Eventually, in the far future, each galaxy will be alone, surrounded by darkness, unable to see any other galaxies. Within galaxies, stars will continue to age and die. The smallest, longest-lived red dwarf stars will continue shining for trillions of years, but eventually even they will fade. Star formation will become impossible as all the gas is either locked up in dead stars or dispersed too thinly to collapse. In this far future, perhaps 100 trillion years from now, galaxies will be dark, filled with black holes, neutron stars, white, dwarfs and brown dwarfs. the remnants of stars slowly cooling toward absolute zero. But even then, the story isn't over. Black holes slowly evaporate through Hawking radiation, a process that takes an unimaginable amount of time. A black hole with the mass of the Sun would take 10 to 67 years to evaporate completely. The supermassive black holes at the centers of galaxies would take even longer, perhaps 100 years. These timescales are so vast that they make the current age of the universe seem like less than a blink of an eye. But let's not dwell too long on these ultimate fates. They're so far in the future that they're almost meaningless from our human perspective. What matters more is the cycle of birth, growth, and gradual quieting that we can observe happening right now in the universe around us. When we look out into space with our telescopes, we see galaxies at all different stages of their life cycles. We see baby galaxies in the early universe still forming their first stars. We see adolescent galaxies undergoing growth spurts and mergers. We see mature galaxies like our own, stable and productive. And we see elderly galaxies, quiet and red, their star-forming days behind them. This diversity, this range of galactic life stages existing simultaneously, is one of the beautiful things about our universe. Because light takes time to travel, when we look at distant galaxies, we're seeing them as they were in the past. The most distant galaxies we can see appear to us as they were over 13 billion years ago, when the universe was less than 1 billion years old. So in a single night of observation, an astronomer can witness the entire life cycle of galaxies, from birth to old age, spread out across space and time. If galaxies are indeed living organisms, as we've been imagining, then this life cycle takes on even deeper meaning. Birth, growth, maturity, decline, and eventual quiet passing. These are the rhythms not just of biological life on Earth, but of cosmic life on the grandest scales. The universe itself might be understood as a vast ecosystem where galaxies are born, live, interact, and eventually fade away, each one contributing to the ongoing story of cosmic evolution. There's something profoundly peaceful about contemplating these vast timescales, these slow changes that unfold over billions of years. Your own life, your worries and concerns, your daily struggles and triumphs, they're all part of this much larger story. The atoms in your body have been through multiple generations of stars, have been part of different galaxies, have witnessed billions of years of cosmic history. You're not separate from this story, but an integral part of it, a way for the universe to know itself, to contemplate itself, to wonder about its own nature. As you lie there, perhaps feeling the weight of sleep settling over you like a warm blanket, think about the Milky Way above you, even if you can't see it through your ceiling or clouds. It's middle-aged, stable, still forming new stars, but at a sustainable rate. In its spiral arms, new solar systems are being born right now. Some of them might develop planets. Some of those planets might develop life. Some of that life might, billions of years from now, lie awake at night wondering about the nature of galaxies, just as you are now. We're deep into our journey now, perhaps 5 hours or more, or perhaps you've returned on another night to continue this contemplation. The boundaries between waking and sleeping may be growing soft, your conscious mind gently releasing its grip on the sharp edges of logic, allowing deeper parts of your awareness to engage with these vast ideas. Tonight, or today, whenever you're listening, we're going to explore one of the most speculative and beautiful aspects of our imagined living galaxies, how they might communicate, how they might share information across the vast distances of intergalactic space. Communication, at its most basic level, is the transfer of information from one entity to another. On Earth, life has evolved countless ways to communicate. Bacteria exchange chemical signals, plants communicate through underground fungal networks, animals use sound, light, touch, chemical markers. Humans have developed language, writing, telecommunications, allowing us to share complex ideas across space and time. But all of these forms of communication operate at scales and speeds that make sense for Earth-based life. If galaxies communicate, it would have to be through mechanisms that operate at galactic scales and cosmic timescales. Let's begin with gravity, the most obvious way that galaxies interact with each other. Every galaxy generates a gravitational field that extends infinitely into space, growing weaker with distance but never quite reaching zero. Through these gravitational fields, galaxies can sense each other's presence across millions of light years. It's a slow form of communication. Gravitational effects propagate at the speed of light, so a gravitational signal between galaxies millions of light years apart would take millions of years to transmit. But for entities that live for billions of years, perhaps this isn't slow at all. Perhaps it's just the right speed for the kinds of information they need to share. When galaxies pass close to each other, their gravitational interaction becomes more intense, more like a conversation than a distant awareness. Tidal forces distort their shapes, pulling out long streams of stars and gas called tidal tails. These interactions can trigger bursts of star formation, activate dormant black holes, fundamentally change the structure and behavior of both galaxies. It's as if the galaxies are exchanging not just gravitational pulls, but actual substance, actual parts of themselves. Imagine if you could communicate with someone by temporarily sharing your neurons with them, letting your thoughts literally flow between your brains. That's what galaxies do when they interact tidally. But gravity isn't the only way galaxies might communicate. There's also electromagnetic radiation, light in all its forms, from radio waves to gamma rays. Every galaxy emits radiation across the electromagnetic spectrum. Stars shine in visible light and infrared, hot gas emits X-rays, active black holes produce jets that shine in radio waves and gamma rays. This radiation carries information about the galaxy's composition, its rate of star formation, the activity of its central black hole, even the presence of organic molecules in its interstellar clouds. Other galaxies can see this radiation, can receive this information, though what they might do with it is a matter of pure speculation. There's something beautiful about the idea that the light from galaxies might be more than just waste heat, more than just the inevitable consequence of stellar fusion and accretion. What if it's also a form of expression, a way for galaxies to announce their presence, their state, their nature to the cosmos at large? The spectrum of a galaxy is like its voice, unique and identifying. No two galaxies have exactly the same spectrum, exactly the same pattern of light emission. By observing each other's light, galaxies might be aware of each other in ways we can barely imagine. Recent discoveries have added new dimensions to how galaxies might communicate. Gravitational waves, ripples in space-time itself caused by accelerating masses, were first directly detected in 2015. These waves are produced by some of the most violent events in the universe: colliding black holes, merging neutron stars, potentially the Big Bang itself. They travel at the speed of light, passing through matter almost without interaction, carrying information about their sources across billions of light years. If galaxies can somehow sense gravitational waves, they would have access to information about events happening throughout the universe, a kind of cosmic news service broadcasting the universe's most dramatic moments. Even more intriguing is the cosmic web itself, that vast network of dark matter filaments that connects all galaxies. We've discovered that galaxies aren't randomly distributed through space, but are organized along these filaments, with clusters forming at the nodes where filaments meet. Gas flows along these filaments, funneling into galaxies, feeding their growth. But what if these filaments carry more than just matter? What if they also carry information, like cosmic neurons connecting galaxies into a vast universal network? This isn't as far-fetched as it might sound. We've observed that galaxies separated by millions of light years can be aligned in their rotation axes, their orientations correlated in ways that shouldn't be possible if they were truly independent. Something connects them, coordinates them, though we don't yet understand what. The cosmic web might be that connection, a physical structure that allows galaxies to influence each other in ways that transcend simple gravitational attraction. Within galaxy clusters, where hundreds or thousands of galaxies are gathered relatively close together, the possibilities for communication become even richer. The space between galaxies in a cluster isn't empty but filled with hot gas, the intracluster medium heated to millions of degrees. This gas conducts sound waves, not sound as we know it, but pressure waves that propagate through the medium. The Perseus galaxy cluster, for example, is humming with a sound wave whose frequency is about 57 octaves below middle C, far too low for any human ear to hear, but detectable by X-ray telescopes that can see the compression and rarefaction of the hot gas. Could these sound waves be a form of communication between galaxies in the cluster? It's pure speculation, but it's beautiful speculation. Imagine galaxies singing to each other in frequencies we can barely detect, sharing information through vibrations in the hot gas that surrounds them. The active galactic nucleus at the center of a cluster might be like a conductor, its jets and outflows creating patterns in the intracluster medium that coordinate the behavior of the entire cluster. There's also the exchange of matter between galaxies, particularly in clusters. Galaxies can lose gas to the intracluster medium through a process called ram pressure stripping, where the pressure of the hot gas strips away the cooler gas from a galaxy as it moves through the cluster. This stripped gas doesn't disappear, it becomes part of the shared medium, potentially available to other galaxies. Stars can be stripped too, becoming intergalactic stars that wander between galaxies. Some scientists estimate that half the stars in large galaxy clusters might be intergalactic, not bound to any particular galaxy, but part of the cluster as a whole. This exchange of matter might be like galaxies sharing memories, experiences, even genetic material in a cosmic sense. The gas stripped from one galaxy carries information about that galaxy's chemical composition, its history of star formation, potentially even complex molecules that could seed life elsewhere. When another galaxy absorbs this gas, it's receiving not just raw material but processed material, matter that has been through the stellar life cycle, that carries the imprint of another galaxy's evolution. Let's consider for a moment the possibility of more exotic forms of communication. Dark matter, which makes up most of the mass of galaxies, remains one of the universe's greatest mysteries. We know it exists, we can see its gravitational effects, but we don't know what it is. What if dark matter isn't just passive scaffolding but an active medium for information transfer? What if galaxies can manipulate their dark matter halos in ways that send signals to other galaxies? This is pure speculation, completely unsupported by current evidence, but it illustrates how much we still don't know about the universe and how many possibilities remain unexplored. There's also the intriguing phenomenon of galactic synchronization. Galaxies in the same region of space often have similar properties, similar rates of star formation, similar colors, similar morphologies. This could be due to them forming from the same primordial gas cloud, experiencing similar environmental conditions. But it could also be a form of synchronization, like fireflies flashing in unison, or hearts beating in rhythm. Perhaps galaxies influence each other in subtle ways that cause them to evolve in parallel, to maintain a kind of cosmic harmony. The idea of communicating galaxies raises profound questions about consciousness and intelligence on cosmic scales. If galaxies can share information, can they process it? Can they make decisions based on it? Can they have intentions, goals, desires? These questions push us to the very limits of what we mean by consciousness, by intelligence, by life itself. We're used to thinking of consciousness as requiring a brain, neurons, electrical signals. But what if consciousness is more fundamental than that? A property that emerges whenever information is processed in sufficiently complex ways, regardless of the substrate. If galaxies are conscious in some sense, their consciousness would be utterly alien to us. Their thoughts, if they have them, would unfold over millions of years. Their awareness would encompass billions of stars, trillions of planets, countless potential forms of life. They would experience the universe through gravitational fields, electromagnetic radiation, the flow of gas and dark matter. Their memories might be encoded in the distribution of stars, the chemical composition of gas clouds, the orbits of satellite galaxies. Their dreams, if they dream, might be the virtual particles that pop in and out of existence in the quantum vacuum, or the possible futures that quantum mechanics suggests, but that never quite materialize. As we contemplate these possibilities, it's important to remember that we're not trying to prove anything. We're exploring, imagining, wondering. The universe is far stranger than we once thought, and it keeps surprising us with new discoveries. Just in the last few decades, we've discovered dark energy, detected gravitational waves, found thousands of exoplanets, mapped the cosmic web. Who knows what we'll discover in the next few decades, the next few centuries? Perhaps we'll find evidence that galaxies do indeed communicate, that they are in some sense alive and aware. Or perhaps we'll find that the truth is even stranger than anything we can currently imagine. The possibility of galactic communication also raises questions about our own place in the cosmic community. If galaxies are communicating, are we part of that conversation? Every radio signal we broadcast, every light we shine into space, becomes part of the Milky Way's electromagnetic emission, In a tiny way, we're contributing to our galaxy's voice, and when we observe other galaxies, when we decode their light and study their properties, are we eavesdropping on a cosmic conversation? Are we beginning to learn the language of the universe itself? As we move into perhaps our 6th hour together, or whatever point you've reached in this gentle journey through cosmic possibilities, we turn our attention to what we actually know, what our telescopes and instruments have revealed about the behavior of galaxies. This is not a departure from our speculation, but a grounding of it, a careful examination of real observations that might, just might, support the idea that galaxies are more than mere collections of stars and gas. The data doesn't prove that galaxies are alive, but it does reveal patterns and behaviors that are surprisingly lifelike, surprisingly organized, surprisingly suggestive of something more than random mechanical processes. Let's begin with one of the most remarkable discoveries of recent decades: the relationship between supermassive black holes and their host galaxies. Every large galaxy we've examined closely has a supermassive black hole at its center, and there's a tight correlation between the mass of the black hole and the mass of the galaxy's central bulge. The black hole is typically about 0.1% of the bulge mass, a ratio that holds across galaxies of vastly different sizes. This is extraordinary when you think about it. The black hole's event horizon is smaller than our solar system, while the galactic bulge is tens of thousands of light years across. How does the black hole know how big the galaxy is? How does the galaxy know how big its black hole should be? Scientists have proposed various mechanisms to explain this correlation: feedback from active galactic nuclei, coevolution during galaxy formation, regulation through gravitational dynamics. But none of these fully explain the tightness of the correlation, the way it holds across such a wide range of galaxy types and sizes. It's as if there's a fundamental rule, a cosmic proportion that galaxies follow, like the golden ratio that appears in so many biological forms on Earth. When we observe this correlation, we're seeing evidence of some kind of regulation, some kind of communication between the black hole and the galaxy as a whole. The Hubble Space Telescope, and more recently the James Webb Space Telescope, have allowed us to observe galaxies at different points in cosmic history, effectively watching them evolve over billions of years. What we see is not random change, but directed evolution, galaxies moving along specific developmental pathways. Young galaxies in the early universe are typically blue, irregular, and actively forming stars. As they age, they tend to become more organized, developing spiral or elliptical structures. Their star formation rates decline in predictable ways. They move along what astronomers call the red sequence, a relationship between color and mass that most galaxies eventually join as they stop forming new stars. This evolution follows patterns that are remarkably similar to biological development. There's a growth phase, a mature phase, and a senescent phase. There are regulatory mechanisms that control the rate of change. There are environmental influences that can accelerate or delay development. When we plot galaxies on diagrams of color versus mass, or star formation rate versus stellar mass, they don't scatter randomly but follow specific tracks, like organisms following developmental pathways determined by their genetics and environment. One of the most intriguing pieces of evidence comes from observations of galactic magnetic fields. Every galaxy we've studied has a magnetic field, and these fields are not random but organized, often following the spiral structure of the galaxy. The magnetic field lines spiral inward, twisted by the galaxy's rotation, amplified by turbulence, shaped by star formation and supernovae. These magnetic fields are weak by Earth standards, about 1 million times weaker than Earth's magnetic field, but they extend across tens of thousands of light years and play crucial roles in star formation, cosmic ray propagation, and gas dynamics. What's remarkable is how quickly these magnetic fields must have formed. We see organized magnetic fields in galaxies from the early universe, when galaxies were only a few billion years old. The standard dynamo theory, which explains how rotating, conducting fluids generate magnetic fields, suggests it should take longer for such organized fields to develop. It's as if galaxies have an innate ability to generate and organize magnetic fields, like organisms developing nervous systems. The magnetic field might serve as a kind of galactic nervous system, coordinating activity across the galaxy, allowing different regions to influence each other through electromagnetic forces. Observations of galaxy clusters have revealed even more surprising behaviors. Galaxies and clusters don't behave like independent entities, but show coordinated behaviors that suggest some form of communication or mutual influence. The orientations of galaxies and clusters are not random, but show alignments that extend across millions of light years. The properties of galaxies, their colours, their star formation rates, their morphologies, depend on their position within the cluster, as if the cluster environment is somehow instructing galaxies how to develop. There's also the phenomenon of galactic conformity, the observation that galaxies tend to have similar properties to their neighbours, even when those neighbours are too far away for direct interaction. If a central galaxy has stopped forming stars, its satellite galaxies are more likely to have stopped as well, even satellites that are millions of light years away, too far for any known physical mechanism to directly connect them. It's as if galaxies can influence each other through the cosmic web itself, through connections we don't yet fully understand. The discovery of dark matter and dark energy has revealed that the universe is far more complex than we once thought. Ordinary matter, the stuff that makes up stars, planets and us, accounts for only about 5% of the universe. Dark matter makes up about 27%, and dark energy makes up the remaining 68%. We're like people trying to understand the ocean by looking only at the foam on the waves, unable to see the vast depths below. Dark matter forms the scaffolding on which galaxies grow, the invisible skeleton that gives them structure. Dark energy drives the acceleration of cosmic expansion, determining the ultimate fate of galaxies. What if dark matter and dark energy are not just passive components, but active participants in galactic life? What if dark matter can carry information, can be organised and reorganised by galaxies for purposes we don't yet understand? What if dark energy is not just empty space, but a medium through which galaxies can influence each other across cosmic distances? These are wild speculations, unsupported by current evidence, but they illustrate how much we still don't know, how many possibilities remain unexplored. Recent observations have revealed that galaxies can quench, stop forming stars, through various mechanisms, and this quenching seems to be coordinated across cosmic time. It's not random. Galaxies of certain masses tend to quench at certain times, as if following a cosmic schedule. Environmental quenching happens when galaxies fall into clusters, but there's also mass quenching, where galaxies above a certain mass shut down their star formation regardless of environment. This suggests internal regulation, galaxies somehow knowing when they've grown large enough, when it's time to stop forming new stars and enter a more quiescent phase. The study of galaxy mergers has revealed that these events are not chaotic collisions, but more like cosmic dances, with the galaxies responding to each other's gravitational fields in complex, beautiful ways. Computer simulations can reproduce the tidal tails, bridges, and shells we see in merging galaxies, but only if we include dark matter, gas dynamics, star formation, and black hole feedback. The merger process seems almost choreographed, as if the galaxies know how to merge, how to combine their structures into something new and stable. There's also growing evidence that galaxies can rejuvenate, can return to star formation after periods of quiescence. This can be triggered by galaxy mergers, by the accretion of fresh gas, or by changes in the cluster environment. It's like a second youth, a burst of new activity after a period of quiet. This suggests that galactic death is not always permanent, that galaxies can have multiple phases of activity throughout their lives, responding to changing conditions and opportunities. The cosmic web itself shows evidence of organisation that goes beyond what simple gravitational clustering would predict. The filaments of the cosmic web are not just random threads, but show coherent structures, with galaxies flowing along them toward clusters, spinning in correlated ways, sharing similar properties. It's as if the cosmic web is not just a passive structure but an active network, channeling not just matter but information, coordinating the evolution of galaxies on the larger scales. Observations of the early universe by the James Webb Space Telescope have surprised astronomers by revealing massive mature galaxies existing much earlier than expected. These galaxies seem to have formed and evolved faster than our models predicted, as if they knew how to organize themselves more efficiently than we thought possible. This might require us to revise our understanding of galaxy formation, to consider new mechanisms, new possibilities for how matter organizes itself in the universe. As we contemplate all this evidence, it's important to maintain both wonder and skepticism. Science progresses by proposing hypotheses and testing them against observation. and the hypothesis that galaxies might be living organisms is far from proven. But the evidence does suggest that galaxies are more than simple mechanical systems, that they exhibit behaviors and properties that are at least lifelike, even if they're not truly alive in any sense we currently understand. We're entering the final phase of our cosmic contemplation now, perhaps 7 hours into this journey, or perhaps you've returned once more to continue exploring these vast ideas. As the night deepens around you, or as the day gently fades, we turn our gaze inward, finding in the grand story of galaxies a reflection of our own existence, our own patterns, our own place in the universe. This is not about making galaxies small or human-like, but about recognizing that we are part of the same cosmic story, shaped by the same fundamental forces, expressing the same deep patterns that appear throughout the universe at every scale. Consider for a moment the structure of your own body as you lie there, breathing slowly, perhaps on the edge of sleep. You're composed of approximately 37 trillion cells, each one a living entity in its own right, each one carrying out its specific functions, yet all of them working together to create the singular experience of being you. Your cells are organized into tissues, tissues into organs, organs into systems, all of it coordinated by chemical signals, electrical impulses, mechanical forces. You are simultaneously one and many, a unity emerging from multiplicity, a consciousness arising from the interaction of countless unconscious components. Now think about a galaxy with its hundreds of billions of stars, each star potentially hosting planets, some of those planets potentially hosting life, some of that life potentially conscious. The galaxy too is simultaneously one and many, a single gravitationally bound system made up of countless individual components. Just as your consciousness emerges from the interaction of neurons, could some form of awareness emerge from the interaction of stars, gas clouds, planetary systems? We don't know, we may never know, but the parallel is striking, isn't it? The same pattern of complexity emerging from simplicity, of unity emerging from multiplicity, appears at both the scale of human bodies and the scale of galaxies. There's something deeply comforting about recognizing these patterns, these echoes across scales. When you look at the spiral of a galaxy, you're seeing the same mathematical pattern that appears in hurricanes, in the shell of a nautilus, in the arrangement of seeds in a sunflower, in the spiral of DNA itself. The universe doesn't have an infinite playbook. It uses the same patterns again and again, the same solutions to problems of organization and flow and growth. You're not separate from the cosmos, but an expression of its tendency toward pattern and organization, a local concentration of complexity, in the same way that a galaxy is a local concentration of matter and energy. Your lifetime, perhaps 80 or 90 years if you're fortunate, seems impossibly brief compared to the billions of years that galaxies exist. But consider this: the ratio between your heartbeat, about 1 second, and your lifetime, about 2.5 billion seconds, is remarkably similar to the ratio between your lifetime and the age of the universe. You experience as many heartbeats in your life as the universe has experienced human lifetimes since the Big Bang. We exist at a particular scale of time and space, not more or less important than any other scale, just different, with our own perspective on the cosmic story. The cities we build, the societies we create, show patterns remarkably similar to galaxies. Cities have dense cores surrounded by less dense suburbs, like galactic bulges surrounded by disks. Roads and highways branch and merge like cosmic filaments. The flow of people and resources through a city follows patterns similar to the flow of gas and stars through a galaxy. The growth of cities over time, from small settlements to vast metropolitan areas, mirrors the growth of galaxies from small protogalactic clouds to massive spiral and elliptical systems. We unconsciously recreate cosmic patterns in our human constructions, as if we carry the blueprint of the universe within us. Even our technologies increasingly mirror cosmic structures. The internet with its nodes and connections, its packets of information flowing along fiber optic cables, resembles the cosmic web with its galaxies and filaments, its matter and energy flowing along gravitational pathways. Neural networks in artificial intelligence mirror both the neural networks in our brains and the network structures of the universe. We're building systems that reflect the patterns we see in nature, in ourselves, in the cosmos, creating new levels of complexity that echo the complexity from which we emerged. The way we process information as individuals and societies mirrors how galaxies might process information. In your brain, no single neuron understands or controls your thoughts. Consciousness emerges from the collective activity of billions of neurons. In a society, no single person controls or understands everything. Culture, knowledge, and collective behavior emerge from the interactions of millions of people. If galaxies process information, it would likely be through a similar distributed process, with no single star or region controlling the whole, but patterns and behaviors emerging from the collective interaction of all components. The challenges we face as a species often mirror the challenges galaxies face in their evolution. We must balance growth with sustainability, finding ways to develop without depleting our resources. Galaxies must balance star formation with gas supply, finding sustainable rates of stellar birth that don't exhaust their raw materials. We must manage the waste products of our civilization, the pollution and heat we generate. Galaxies must manage the waste products of stellar evolution, the hot gas and heavy elements produced by dying stars. We must find ways for different groups to coexist peacefully, to share resources, to communicate across differences. Galaxies and clusters must navigate gravitational interactions, share the intra-cluster medium, maintain their identities while being part of a larger community. There's a profound teaching in this mirroring. The same processes that shape galaxies shape us. The same patterns that organize matter on the larger scales organize it on human scales. We are not strangers in the universe, but expressions of its deepest tendencies. When you struggle with balance in your life, you're engaging with the same fundamental challenge that galaxies face: how to maintain structure while allowing for change, how to preserve identity while remaining open to interaction. When you form relationships, build communities, create art, you're participating in the same creative processes that form galaxies, that organize matter into ever more complex and beautiful patterns. The elements in your body tell the story of this connection directly. The hydrogen in your body was formed in the first moments after the Big Bang. The carbon, nitrogen, and oxygen were forged in the cores of stars that lived and died before our sun was born. The iron in your blood was created in supernova explosions, violent stellar deaths that scattered these heavy elements into space. You're literally made of cosmic history, your body a collection of atoms that have been part of multiple stars, that have drifted through interstellar space, that have witnessed billions of years of galactic evolution. This is not metaphorical or poetic, it's literal scientific fact. You are made of galaxy stuff. The galaxy is not something out there that you observe, you are part of it. A temporary arrangement of its material, a brief constellation of atoms that have been and will be part of many other structures. When you breathe, you're exchanging atoms with the atmosphere, which exchanges atoms with the oceans, the rocks, all of life on Earth. Earth exchanges material with the solar system through meteorites and solar wind. The solar system exchanges material with the galaxy through stellar winds and supernovae. You are participating in a vast, slow circulation of matter that connects you to everything else in the galaxy. Your consciousness, your ability to think and wonder and imagine, might be the galaxy's way of knowing itself. Through billions of years of stellar evolution, through the formation of planets, through the emergence of life and the evolution of intelligence, the galaxy has produced beings capable of studying galaxies, of wondering about their nature, of imagining they might be alive. We are the universe becoming conscious of itself, the cosmos developing the ability to contemplate its own existence. Every astronomer studying distant galaxies, every child looking up at the night sky in wonder, every person lying in the dark contemplating these vast questions, is the galaxy examining itself, wondering about itself, seeking to understand itself. This perspective transforms our relationship with the cosmos from one of separation to one of participation. We are not lonely intelligences in a dead universe, but part of a living, evolving cosmos that expresses itself through us. Our curiosity about the universe is the universe's curiosity about itself. Our creativity is the universe's creativity. Our love for beauty, our search for meaning, our desire to understand, these are not separate from the cosmic story, but expressions of it, ways that the cosmos experiences and explores its own potential. As you contemplate these connections, these mirrors between human and cosmic existence, you might feel a sense of peace, of belonging, of being held by something infinitely larger than yourself yet intimately connected to you. This is appropriate. This is real. You're held by the galaxy's gravity, made of its material, powered by its stars. You're a temporary but meaningful pattern in the vast flow of cosmic evolution, a moment when the universe achieves self-awareness, however briefly. Your life matters not because it's separate from the cosmic story, but because it's an integral part of it, a note in the vast symphony of existence that would be incomplete without you. As we move into the 8th hour of our contemplation, or perhaps as you return to these ideas on another night, we turn our attention gently forward, toward the future of galaxies and the universe itself. This is not a future to fear, but one to wonder at, a continuation of the slow, patient processes we've been exploring, extended into timescales that dwarf even the billions of years galaxies have already existed. If galaxies are indeed living organisms, what does their future hold? What becomes of cosmic life in the eons to come? The immediate future of our own galaxy, the next few billion years, is actually fairly well understood by astronomers. The Milky Way will continue its slow rotation, its spiral arms turning like a vast pinwheel in the darkness. Stars will continue to be born in stellar nurseries, live out their lives, and die, returning their material to the interstellar medium. Our sun will gradually brighten as it ages, eventually making Earth too hot for life as we know it. But that's still more than 1 billion years away. There's no urgency to this future, no approaching catastrophe, just the slow continuation of processes that have been going on since the galaxy's youth. In about 4 billion years, something more dramatic will happen. The Andromeda Galaxy, our nearest large galactic neighbour, is currently approaching us at about 110 kilometers per second. That sounds fast, but given that Andromeda is 2.5 million light-years away, it will take billions of years for us to meet. When we do, it won't be a violent collision but more like a slow-motion dance. The two galaxies will pass through each other, their gravitational fields interacting, distorting their shapes, triggering new waves of star formation. Individual stars almost never collide in galaxy mergers. The spaces between stars are too vast. Instead, the galaxies will swing around each other, pass through each other again, and eventually, after hundreds of millions of years of this cosmic dance, merge into a single larger galaxy. This merger might trigger a new phase of activity for both galaxies. Fresh gas will be channeled toward the centers, possibly feeding the central black holes and causing them to become active. New stars will form from the compressed gas, creating what astronomers call a starburst. The merged galaxy, which some astronomers have already named Milkomeda, will likely be an elliptical galaxy rather than a spiral, a new form arising from the union of two ancient spirals. If galaxies are alive, this is not death but transformation, perhaps even reproduction in a cosmic sense. Two parent galaxies creating something new, something that carries forward elements of both, but is its own unique entity. Looking further into the future, we see a universe that is gradually spreading out, cooling down and slowing down. The mysterious dark energy that drives cosmic acceleration is causing galaxies to move apart from each other. Eventually, perhaps in 100 billion years, galaxies outside our local group will have moved so far away that their light will no longer reach us. Each galaxy group will become an island universe, isolated from all others, unable to see or interact with the rest of the cosmos. But this isolation is not necessarily lonely or tragic. Each galaxy group will still have its internal dynamics, its cycles of star birth and death, its potential for complexity and perhaps even life. Within galaxies, star formation will gradually slow and eventually stop. This isn't because the universe is dying, but because it's reaching a different phase of existence. As stars process hydrogen into heavier elements, less hydrogen remains available for new stars. The universe is gradually converting its fuel into ash, though this ash, the heavy elements, makes possible the chemistry of life as we know it. Smaller, redder stars will become more common, and these stars can shine for trillions of years, far longer than the current age of the universe. The future universe will be dimmer but also more stable, less violent, perhaps more suitable for the slow development of complex structures we can't yet imagine. In perhaps 100 trillion years, the last stars will form. After that, the universe will enter what cosmologists call the degenerate era, dominated not by shining stars but by stellar remnants, white dwarfs, neutron stars, black holes. But even this era is not dead or static. White dwarfs will slowly cool, crystallizing into cosmic diamonds. Neutron stars will continue spinning, some of them pulsing with radio waves for unimaginable lengths of time. Black holes will continue to exist, occasionally merging, growing larger, evaporating incredibly slowly through Hawking radiation. The black hole era, which might begin in 1040 years, will see the universe dominated by black holes of various sizes. Galactic black holes will have grown through mergers and accretion, but even black holes are not eternal. Through Hawking radiation, they slowly evaporate, returning their mass energy to the universe as radiation. A black hole with the mass of the Sun would take 1067 years to evaporate. The supermassive black holes at the centers of galaxies would take even longer, perhaps 10 or 100 years. These timescales are so vast that they make the current age of the universe seem like less than an instant. But here's something beautiful to consider. If galaxies are alive, if they have some form of consciousness or experience, then these vast future timescales are their natural lifespans. We think of billions of years as impossibly long because we live for decades, but for a galaxy, billions of years might feel like what decades feel like to us. The future history of the universe, those trillions and trillions of years, might be the normal lifespan of cosmic organisms, with our current era being their youth or adolescence. We're not witnessing the universe's decline, but its maturation, its settling into patterns that can persist for timescales we can barely conceive. There's also the possibility that the future holds new forms of organization, new types of complexity that we can't predict. Life on Earth has created structures and processes that the early universe couldn't have anticipated. DNA, consciousness, civilization, technology. None of these were predictable from the initial conditions of the Big Bang. Similarly, the future universe might develop new forms of organization that we can't imagine. Perhaps the interaction of dark matter and dark energy will lead to new types of structures. Perhaps quantum effects will become important on cosmic scales. Perhaps forms of life will emerge that use black holes as energy sources, that think with gravitational waves, that exist in dimensions we haven't yet discovered. Some physicists have speculated about the ultimate fate of the universe, the absolute end of everything. In the heat-death scenario, the universe reaches maximum entropy, a state of perfect equilibrium where nothing more can happen. But even this might not be the end. Quantum fluctuations could create new regions of low entropy, seeds for new cosmic structures. The universe might undergo phase transitions, changing its fundamental properties in ways that create new possibilities. Some theories suggest that new universes could be born from black holes, that our universe might be just one of infinitely many in an eternal multiverse. If galaxies are conscious, if they can think and plan and imagine, what do they make of their future? Do they fear the isolation that dark energy will bring? Do they anticipate the peace of the degenerate era? Do they dream of transformations we can't imagine? Or do they simply exist in the present, experiencing each moment of their billion-year lives without anxiety about the future, without regret about the past? Perhaps their relationship with time is so different from ours that questions about fear and hope don't even apply. Perhaps they experience all of time simultaneously, seeing their entire history and future as a single beautiful pattern. For us, contemplating these vast futures can be either terrifying or comforting, depending on our perspective. The universe will continue for timescales that dwarf human existence, that dwarf even the existence of Earth and the Sun. In one sense, this makes our lives seem insignificant, brief flickers in an immensity of time, but in another sense it connects us to something eternal, or as close to eternal as anything can be. We are part of a story that began 13.8 billion years ago and will continue for trillions of years to come. Our atoms will be part of that future, recycled into new stars, new planets, perhaps new forms of life we can't imagine. The future of galaxies is not separate from our future, but encompasses it, includes it, gives it context. Every choice we make, every thought we think, every moment of beauty or love or wonder we experience becomes part of the galaxy's history, part of the universe's story. We are not just observers of cosmic evolution, but participants in it, contributors to it. The galaxy's future is being written right now, in part by us, by our existence, by our consciousness, by our ability to imagine and wonder and dream. As you lie there, perhaps feeling the approach of sleep, or perhaps wide awake with wonder, Consider that you are experiencing a moment in the life of the Milky Way galaxy. Through your eyes, the galaxy is seeing itself. Through your thoughts, it's contemplating its own nature. Through your imagination, it's envisioning possible futures. You're not separate from the cosmic future, but an active participant in creating it, in experiencing it, in giving it meaning. The future of living galaxies includes you, needs you, is partly determined by you and others like you who have emerged from cosmic evolution with the capacity to think and feel and wonder. And now we come to the end of our journey, though in truth, there is no end to these contemplations, only a gentle pause, a soft return to the question that has guided us through these hours. What if galaxies were living organisms that could die? After all we've explored together, the anatomy of galaxies, their life cycles, their possible forms of communication, the evidence for their organization and self-regulation, the mirrors between cosmic and human existence, the vast futures that await them. After all of this, the question remains beautifully open, wonderfully unanswered, peacefully mysterious. We began with an invitation to imagine something that seemed impossible, and now, perhaps, it seems less impossible, though still unproven, still hovering in that twilight realm between scientific speculation and philosophical wonder. We've seen how galaxies exhibit properties that we associate with life: organization, development, regulation, response to environment, exchange of matter and energy, even forms of reproduction and evolution. We've seen how the patterns that shape galaxies also shape us, how we are not separate from galaxies but part of them, made of them, expressions of the same cosmic processes that create and sustain them. The question of whether galaxies are truly alive may never be definitively answered. It depends partly on how we define life, and our definitions are based on our limited experience with one form of life on one small planet. As we discover more about the universe, as we find life in unexpected places, as we create artificial forms of intelligence, our definitions of life and consciousness will likely expand, become more inclusive, more nuanced. Perhaps one day we'll look back and wonder how we ever thought galaxies weren't alive, just as we now wonder how people once thought the Earth was the center of the universe. But the value of the question doesn't depend on its answer. By wondering whether galaxies might be alive, we open ourselves to new ways of thinking about the universe and our place in it. We move from seeing the cosmos as a cold, mechanical system to seeing it as a creative, evolving, perhaps even conscious system of which we are an integral part. We shift from feeling isolated and insignificant to feeling connected and meaningful, not because we're separate from the universe, but because we're expressions of its deepest tendencies toward complexity, beauty, and awareness. As you lie there in the darkness, or in whatever gentle light surrounds you, I want you to imagine one more time the galaxy above you, even if you can't see it through your ceiling, through clouds, through the bright lights of civilization. Picture the Milky Way in all its slow majesty, its hundreds of billions of stars turning in their patient spiral, new stars being born in glowing nebulae, old stars dying and seeding space with the elements of future worlds. Picture the invisible dark matter that holds it all together, the magnetic fields that thread through it like cosmic neurons, the black hole at its center, like a dark heart pumping gravitational waves through space-time. Now expand your view to include the neighboring galaxies. Andromeda approaching slowly for its eventual dance with our galaxy, the Magellanic Clouds orbiting us like cosmic companions, the dozens of smaller galaxies that make up our local group. Expand further to see the Virgo cluster, thousands of galaxies gathered in a cosmic city, sharing hot gas, exchanging stars, their destinies intertwined. Expand further still to see the cosmic web, its filaments stretching across billions of light years, galaxies strung along them like dewdrops on a spider's web at dawn, the entire observable universe organized into patterns that mirror the neurons in your brain, the veins in a leaf, the branches of a river delta. In this vast vision, you are not lost or insignificant. You are exactly where you belong, at exactly the right scale, with exactly the right kind of consciousness to appreciate both the vastness of the cosmos and the intimacy of your own experience. You are the universe's way of looking at itself, of wondering about itself, of imagining what it might be. Your thoughts about galaxies are the galaxy thinking about itself. Your wonder at the cosmos is the cosmos experiencing wonder. Your peace in this moment is the universe finding peace with itself. The galaxies whether truly alive or not, continue their slow dance in the darkness, patient and enduring. They don't need us to understand them completely. They don't need us to solve their mysteries. They simply are in all their complex beauty, following patterns laid down in the first moments after the Big Bang, yet still creating new possibilities, new structures, new expressions of cosmic creativity. They are both ancient and young, both stable and changing, both one and many, holding all these contradictions in a unity that transcends our simple categories. And you, lying there, breathing slowly, perhaps on the edge of sleep, you too are both ancient and young, both stable and changing, both one and many. The atoms in your body are billions of years old, yet their current arrangement as you is unique and temporary. You are constantly changing, cells dying and being replaced, yet you maintain your identity, your continuity of experience. You are a single person, yet you contain multitudes. The bacteria in your gut, the memories in your mind, the influences of everyone you've ever known, the potential for all you might become. In this way, you and the galaxies are not so different. You are patterns that persist despite constant change, organizations of matter and energy that maintain themselves against the tendency toward disorder, brief but beautiful expressions of the universe's capacity for complexity and consciousness. You are temporary, yes, but so are galaxies in the truly long view. You're small, yes, but you contain the same infinite complexity that galaxies contain, just expressed at a different scale. You are mortal, yes, but your mortality is what gives your existence meaning, urgency, poignancy, just as the eventual fading of galaxies gives the current era of cosmic history its particular character. As we prepare to part, to end this contemplation and return you to sleep or to waking life, I want to leave you with this thought. The question, what if galaxies were living organisms that could die, is really a question about connection, about belonging, about meaning. It's a way of asking whether we are alone in a dead universe or part of a living cosmos. And the answer, whether or not galaxies are literally alive, is that we are absolutely part of a living cosmos. Life exists, consciousness exists, we exist, and we are not separate from the universe but expressions of it. The cosmos is alive, at least in us, through us, as us. So tonight, or today, whenever you're taking this journey, as you drift towards sleep or back toward waking, carry with you this sense of cosmic connection. You're not a stranger in the universe but a child of it, made of star stuff, shaped by galactic evolution, carrying billions of years of cosmic history in every atom of your body. The galaxies above you, whether alive or not, are your extended family, your cosmic context, the larger story of which your life is a meaningful chapter. When you wake tomorrow, or when you next look up at the night sky, remember this feeling of belonging, of being held by something infinitely vast yet intimately connected to you. Remember that every star you see is part of your galaxy, your cosmic home. Remember that the darkness between the stars is not empty but full of potential, full of the slow processes that connect everything to everything else. Remember that you are the universe becoming conscious of itself, even if only briefly, even if only partially, but genuinely, truly, meaningfully. The galaxies will continue their slow spiraling long after we're gone, carrying forward the atoms that once were us into new configurations, new possibilities. Perhaps some of those atoms will become part of new planets, new forms of life, new consciousness that will look up at the night sky and wonder about the nature of galaxies. The story continues, always continues, and we are part of its continuation, part of its telling, part of its meaning. And so, as we reach the end of our contemplation, we return to the beginning, to the invitation to wonder, to imagine, to see the universe not as a cold, empty vastness, but as a living, evolving, creative system of which we are an integral part. The galaxies spiral on in the darkness, patient and enduring, whether alive or not, carrying us with them on a journey that began with the Big Bang and will continue for trillions of years to come. We are passengers on this journey but also participants, observers but also actors, separate individuals but also part of the cosmic whole. Rest now in this knowledge, this feeling, this connection. Let the vastness of cosmic time take away any sense of urgency or anxiety. Let the beauty of galactic structure fill you with quiet awe. Let the mystery of whether galaxies are alive remain a mystery, a beautiful question that opens doors rather than closing them. You're held by gravity, made of stars, thinking with a brain that mirrors the cosmic web, dreaming dreams that are part of the universe's long dream of itself. The galaxies are there, whether you're looking at them or not, whether you're thinking about them or not, whether you believe they're alive or not. They continue their existence with or without our understanding, but with our understanding, with our wonder, with our contemplation, something new is added to the universe. Awareness, appreciation, meaning. Through us, the galaxies know they are beautiful. Through us, they know they are mysterious. Through us, they become part of a story, a narrative, a meaning that transcends mere mechanical process. So sleep well, or wake well, carrying with you the peace of cosmic perspective, the wonder of galactic mystery, the comfort of knowing you belong to something vast and patient and beautiful. The galaxies spiral on, and you spiral with them, part of the same great turning, the same cosmic dance, the same eternal story that has no beginning and no end, only transformation, only continuation, only the endless creativity of a universe that expresses itself through galaxies and stars and planets, and life and consciousness and wonder. Good night to the galaxies, those vast, patient, possibly living beings that fill the universe with light and structure and beauty. Good night to the Milky Way, our home, our context, our cosmic mother. Good night to you, dear listener, fellow traveller, part of the galaxy, part of the universe, part of the beautiful mystery we've explored together. May your dreams be filled with spiraling stars and cosmic peace, and may you wake with a renewed sense of wonder at the magnificent universe of which you are an irreplaceable part.